bonds up there. How can we do that? So I'm going to have 1 diamond, 2 diamonds. So that's going to go to there. I got to use a line. I didn't want to, but all right, now double bond on this sulfur here. We take green because sulfur's in the same family as the oxygen. And we're still going to, we could draw it as a circle, but we're going to stick with this 6-membered star thing. So let's go. And this way we just go 1, 2. That's it for the sulfur. I like putting a little yellow around it because there's lots of electron density here. So you can even do green too, but sulfur is yellow. That was the color of the star, just like these are blue and black. Okay, so the Schroeder diamonds are the ones that have all the significant bonds to them. There's no hydrogens. If they're not highly electronegative like this one, they don't get it. So this one gets black. These double bonds are going to make these guys really bound. So that gets black. This one down there gets black. Now I say I do these before I do the hydrogens. So I go through and it lets you concentrate. All right, now we go to making these ends into little aliens. That's where all the fun was, remember? And we look through and we see these ends. If there's a double bond, there's going to be no H, but if there isn't, it's going to be NH. A lot of books leave out the H's because of their short note taken, whatever. So out of the 4 ends, notice 2 of these have H's. The other 2 have double bonds. So do 2 different natures of the nitrogens there. So we could color those different too. We'll color one with our regular blue. Call this ammonium blue. And see, we know it's a nitrogen because it's the triangle. There's no getting that mixed up. Let me finish this carbon here just since I was looking at it. Okay, so that's 1H. This here is 1H. So you catch yourself. It really makes you think. Before you color it a color, you're going to make sure of the number of hydrogens that that carbon has on it. So we need a different color blue here for the nitrogen with the double bond. Oh, see, I did those wrong. Those were 2 different kinds. One with the double bond, one without. So I just messed that up. Like I said, you can do it that way. You don't have to do any of this any way that I do. The whole idea is that you're going to do this your own way eventually. So what did I do wrong? I should have had that sulfur bigger too, right? That sulfur should be humongous. Bigger, huh? Can we draw that bigger? There you go. Mercapto purine. All right, now what do we got here? We got cisplatinum. This is one of the chemo drugs. Platinum will start disrupting cell multiplication in cancerous cells, hopefully. So this is one of the chemo ones, heavy metals, they'll call them, the poisonous ones. This is one of them. Be right back. Okay, so the platinum is in group 2, but we're going to draw platinum as a diamond. So it's going to get 4 bonds here. Platinum is used a lot when electron densities are being considered. So 2 chlorines here is just going to give us a square and a square. So we've been drawing pairs and stuff on it. But that's all there is for halogen. So chlorine usually is given the green color, so we'll make these electron pair alien kind of like things here if you want. Do whatever you want to make it more learningful for you. Now it looks like 2 ammonias hanging off there, huh? It's no biggie. We just draw a right-angled N. Oh, wait, though. Look what it's going to be. NH3s. It's going to put a plus on that. Well, let's see where it goes. Right angle. Right angle, right angle. So what we do in this case, one of the little electron pair aliens, what he ends up doing is holding a proton through what we call the mind meld. So we end up with a plus on the end because it's going to be 1, 2, and then another little plus out there on the alien. So down here, same thing. 1, 2, 3. So it's NH3s bound to the platinum. Now the way they had it looked like a covalent bond. Platinum does plus 4s. It does plus 2s, so we're calling this the plus 4 ion. But it could be that 2 ammonias are just held, not covalently, which would give it a plus 2, but apparently this is a plus 4. So platinum is silver, and we had a silver crayon somewhere, and we kept throwing it back in the box. We've got ends here. Let's see where our colored pencils work in this. Really good, huh? Oh, I didn't put the plus in there, did I? And I shouldn't have colored that in. So if you want, you could put the plus outside. But you got to realize that N has a different character to it. And what color are the chlorines? Green. How about that? So these chlorines will fall off in water real easy. These with the plus, they're going to fall off real easy. So what you'll be left with essentially is a PT plus 4 in what's called an aqueous environment, which means it's ionized. So it's ionized in solution with a plus 4 charge. Now it can go and be taken up by tissue and do its damage. Aqueous oil is in parentheses. So there you go for that, cisplatinum. Now we're on to some bigger molecules. The tropsin. Oh boy, we're going to be able to fit all this on there.